Okay, so starting with number 8 on this Illuminate study guide. And hopefully it doesn't take forever to load like this. Let me open it in another one just in case. Okay. So again, I'm giving you like free answers, but you should also just listen to the explanations in general. Because yeah, you could honestly probably get all these answers from your friends, but you got to actually know how to do it tomorrow. I will do everything I can to make sure you are not able to cheat on the actual thing. So yeah, you should probably know how to really do it. So for this one, the most missed one on the study guide, we have to pick all the equations that could be defined by this graph. So see what the graph is giving you. What is it showing? Table 6, can you tell me? What is the graph making really clear? The vertex. So what of our forms that we've learned of our quadratic function, which equation is really easy to see the vertex from? We have a few forms. I'll write them over here. Maybe consider making some note cards and pushing everyone to do that. Which form do you think is easiest to see the vertex form from? Or the vertex from? Table 4, can you tell me? It's really gonna work if we're not paying attention. Then I'm just like up here wasting my time. So which of these 3 forms that we learned about do you think is easiest to identify the vertex from? Yes. Okay, vertex form, whoever said that. Not sure if it came from table 4, but you know, it just takes forever. We only get like 30 minutes together. When you guys just choose not to answer. 1 out of 3 chance. But yeah, vertex form, it's in the name. You can easily see the vertex from it. Table 5, can any of you remember what that equation is for vertex form? It's one that I'm not providing on the test, so I just kind of want to see like what we remember of it. Maybe if we look at some of our answer options, maybe that'll jog some of your memory. Table 5, can you tell me which of these options are even in vertex form? Did you say a second one? The first 2 are in factored form. And I know it might be hard to see on my screen. But the first 2 are factored form. We'll talk about those in a second. Okay. Third, as in this one, that's actually our standard form. So standard. And this one you also pointed out. So that means all the other ones you guys didn't say are my vertex form. Okay, so vertex form looks something like this. Hopefully, like if you forget the formula on the test, maybe you can look at ones that are in vertex form and it reminds you. But that formula is y equals a parentheses x minus h squared plus k. So it looks something like this. And it's really easy to tell what the vertex is. What letters do they denote the vertex from this formula? Table 7, can you tell me? Based on this equation, they say the vertex is which numbers? So just tell me which of these letters, you have like 5 options of letters to pick from. Which letters tell me the vertex? The K would give me the Y of the vertex. What gives me the X of the vertex? The H, good. All right, so everyone paying attention, everyone. Good. Okay, so vertex form. Since it tells me my vertex on the graph, I can clearly see that my vertex is 4, -9. I can use vertex form. You, of course, would have to memorize this formula, but I believe in you. Memorize it, be able to identify it from something. And where there is an H, it looks like I'm plugging in a 4. And where there is a K, it looks like I'm plugging in a -9. Which of these options best matches what I just wrote right here, plugging in the vertex into vertex form? Table 1, can you tell me? So there's only 3 options that I said are even in vertex form. Can we look at them and see which one best matches the one I just wrote down and boxed up? So this one. Okay. So it can only be one of the vertex forms. It can't be multiple. So since we've identified this would give me the correct vertex, or -9, and right there, then that means it can't be the other ones that we said are vertex form. So it can't be this one, and it cannot be this one. Now, the rest, we could get the standard form from expanding out the correct vertex form, but I think there will be an easier way. See if it matches any of the factor form. But really, once you've matched one, you could just use Desmos, type it in, and see which other ones that you type in give you the exact same graph. But you have to be able to identify at least one of the correct ones from the graph. This is really similar to your constructed response. But now we're gonna pick which, if any, of these factor forms is gonna be correct. Table 2, can you tell me for factor form, what's really easy to see from our factor form? When it looks like these. What's something you've identified really easy from factor form? The x-intercepts, good. So what would be my zeros for this first equation that's in factor form? Anyone want to jump in? What would be my zeros for x plus 1, x plus 7? For 0, that's not going to be it. Okay, 1 is not going to be it either. Because you have to think what makes the parentheses 0. X-intercepts by definition are when y equals 0. So if this is supposed to equal 0 and I'm solving for x, there's 2 ways to get there. One is for the first parentheses to equal out to 0, and one is for the second one to equal out to 0. So what plus 1 will give me 0? So one of my zeros for this first equation is going to be -1. Does that match my graph? Does my graph have a 0 at -1? It doesn't. So it can't be the first one already. Just based off of that. It could possibly not be the other factor form, so that's why you still kind of have to check. But for this one, what would have to be the x to make this parentheses 0? What minus 1 gives me 0? So then one of my zeros for this one is 1, which does match the graph. I'll scroll up and prove it to you. But then the other one, what minus 7 will give you 0? Right into that. Maybe even write down these answers, so then we hear from the later if you die. Positive 7. So C, does that match the graph? Does it have zeros or x-intercepts at 1 and 7? So then we should pick that. The second. Now we have to compare to the standard form, and now that we have our factored form, I think that one's easiest to go from factored to standard. So factored form, we said that this one is correct. I know there's a lot of writing, but I don't want to erase any of it in case someone wants to take notes. But we said this is the correct factored form. We know that if we distribute this out, that I can get my standard form. So table 3, what's x times x? Good. Table 4, what's x times negative 7? When you guys don't make eye contact with me and you're just staring at your screen, I assume you're playing games. So table 4, x times negative 7. Thanks, Jordan. Negative 7x. Table 4, inner terms. What's a negative 1 times x? Very good. Table 5, negative 1 times negative 7. Positive 7. And I can combine like terms for sure. Table 6, what's negative 7x plus negative 1x? Negative 7x plus negative 1x combines to give me what? No, that would be maybe multiplying. We gotta combine means add. So negative 7x plus negative 1x. Combine the coefficients. What's negative 1 plus negative 7? So basically, is my answer gonna be C or F? It's negative 8x. Okay, good. You guys are making me sad and scared. Are we okay? All right, well, now we found our answer. It's gonna be these 3. And of course, they could be shuffled on your screen, so make sure you pick the right ones. This is the most missed question on the test. And you do have one on your constructed response, just like it. If you are seriously struggling, you get to this question on the test and you have no clue how to do it. Type in all the answers into Desmos. See which ones line up with this graph exactly. Same x-intercept, same vertex. If it doesn't, then don't pick that answer. But it can never be more than one factored form, more than one standard, or more than one vertex. So the maximum options you should be picking on your test tomorrow would be 3. Okay, good on this one. All right, finally on to the next one. All right, so the next most missed one is number 10. That's the one we're gonna do next if you want to follow along. Hopefully you guys can at least get one submission in before stride ends, no matter what it is, so that it's just better than a 0. But here it is. Line of symmetry is what it's asking for. There is an equation for line of symmetry. Does anyone have it memorized yet? That might be another thing you want to make a note card for. just as a recommendation. I'm not providing any formulas tomorrow. But line of symmetry does have a formula. And it's x equals negative b over 2a. So when you go to type your equation for the line of symmetry, you need to have it be x equals, because the equation has an equal sign and it has to be x equals. Why, you might ask? Well, when something is symmetric, that means it's a mirror image when you draw your line of symmetry. So my quadratic functions only look like this or this. And we've learned before that vertical lines are given by x equals and numbers. Okay, so remember that. It has to be x equals or it's wrong. But the rest you can calculate from this formula. The a and the b come from ax squared plus bx plus c. So then table 7, what number is going to be my b in this one? I'll try to zoom in, but what's going to be my b? No, 2 will be my a because 2 is in front of the x squared. So try again, table 7, what's going to be my b? Eight. So no matter what order they write it in, they did write it out of order. A is always in front of the x squared. B is always in front of the x term. So when it plugs in, you see it is plugged in B and A. The numerator becomes -8. The denominator is 2 times 2, which is 4. And what's -8 divided by 4? Class. And that's what my equation is going to be. It's x equals -2. Don't put any extra spaces or it'll mark it wrong. That's how it'll be on your test tomorrow too. I imagine I'll have to go back and get some points. But that's the answer. And when you go and type this into Desmos, maybe you want to check your answer. Maybe you again have no clue what you're doing and need to figure it out some other way. Maybe half of the tests can be done from figuring something out in Desmos. So don't just completely give up. If you have extra time, go back, check your answers, see what you can come up with. But here's the same equation I was given, and here's what we calculated the line of symmetry to be. Does it go right down the middle? So then I know I have my answer correct. Also, look what else goes right down the middle. Your vertex. So if you can also remember that your line of symmetry is going to be x equals whatever the x is of your vertex, and that's another thing you can do. Good on this one? Okay, so then the next most missed one is number 9, so we'll look at that one next. Okay. So this one says select all statements that could describe the transformation of the following quadratics. So whenever we're asking about transformations, unless it gives you another equation to compare it to, then we're comparing it to the parent function, which is x squared, the most basic quadratic that we can have. And this is vertex form. We talked about what each of the numbers in vertex form do. We talked about it, and you can memorize that. But if that's too much to memorize, you could also just try the strategy in Desmos, which is really similar to what we did when we did the lesson. And that's to graph your parent function, which is x squared, and then graph the graph that they're asking you to compare it to. So -2 parentheses x plus 3 in parentheses squared plus 4, like that. And now you can see visually what the changes are going to be. So green is my original, purple is my transform. How would you describe that it moved? I think the best way to look is like compare the vertex. Did it go up, down, left, right? And it went up how many? It went up 4. What else happened? It went left 3. So that gives us 2 of the answers, but there's other things going on too. So it went up 4, left 3. How did it go from an upward U to a downward U? What do we call that? Okay, good. And that happens because of the negative A. But also look, we have a value for A that is not 1. We have it as a 2. And visually, you might be able to tell from the graph. Personally, I didn't. I couldn't tell. But would you say that our transformed graph is more narrow or more wide than the original? And would that match stretched or compressed? So 4 transformations in this one. You would need all 4 to get the full ones. Doesn't mean there will be 4 transformations tomorrow, but like you can see what number tells you if it goes up or down, what number tells you if it goes left or right, what number tells you if it reflects or gets wide or narrow. When in doubt, use decimals and compare. But always compare it to x squared, unless it tells you otherwise. So good on that one? Okay, so then let's see. Next most missed one is number 3. All right, so a projectile is fired into the air. The equation below can be used to determine the height after t seconds. What's the domain and range of the function? Domain refers to all the what in the situation? All the x's. And range refers to all the what? So remember that. An easy way to remember that is Dr. XY. We know domain is for the x's, range is for the y. It would help to think about how your axes would be labeled. So we're comparing height and time in seconds. What should go on the x, height or time in seconds? Time is almost always on the x-axis. And the reason why we care right now is because when I ask you what's a reasonable domain, you have to think what's a reasonable amount of seconds. Like, can I have negative seconds? Can I have decimals of the second? So that will help us pick the answer. Also notice like in our answer options, they have intervals. So you might want to graph this and see where it starts and ends on the x-axis. So that's what I'm going to do right now. I'm going to change the t's to x's just so that it gives me something. Otherwise, it usually doesn't do t's. All right, so here's our graph. Domain is for the x's, so I'm looking at the x-axis. We talked about how we can't have negative time, so I'm only going to look at where the x's are positive. And it starts at 0, ends at 3 for the domain. So I'm not going to pick A on mine, which says 16 to 48. I'm not going to pick C that says 0 to 36. But on these 2 answers that go from 0 to 3, one says all whole numbers and one says all real numbers. Which one's going to be the answer? The one that says all real numbers. Because that would include decimals, which we talked about already. Time can be a decimal. Like 2.5 seconds, that's totally possible. Not whole numbers. So even just from that, I can find my right answer. But just in case you wanted to know for the range, we can't have a negative height. So I have to start at 0 for the range. And then go all the way up to the highest y value, which is 36. And then can you have a decimal of a foot or a meter? You could. So that's why that's truly the right answer. All right. We may or may not have time for one more. But do me a favor, even if like you're not done with this submission of your study guide, can you just submit it at least once so that way it's better than a 0? I have it queued up for 3 attempts. I can always delete one of your attempts if you really need another one. But I just don't want so many missing for this study guide that's worth 100 points. So please submit from the answers we went over, maybe submit a guess for the others. I need at least one submission from each of you. I will go back and check. Questions? Okay. Same if I told you to do the optional one, if you could just submit what you have